I said casually. All right, we're going to get started. I'm going to tell you how today is going to run. I want to get started with a quizzes as soon as possible. I need to write something down for you first so that you have it in your notes. But then I want to get that quizzes done as soon as possible because my objective for today is to see where we're at with these types of problems. So you will be able to use your notes, you will be able to use your calculator, of course, but I want to make sure that I see where we're at with this logarithm type situation and with these exponential word problems that we're going to have to do, because it will help better inform what we do moving forward. So, if you would, ladies and gentlemen, I see there's only one person in the chat so far, but I'm already live. So if you would leave comments in the chat, that'd be wonderful if I can see what's going on. But as for the rest of you, I'm going to need those notebooks out and open. I said I had to write something down for you real quick beforehand. I think you stopped listening after the word quizzes.
Yeah.
This quizzes is a practice. Oh, because grades are due Friday. Yes. Well, because we are required to get in a minimum number of assessments. I don't like it or agree with it, but it is a requirement of my job. And, well, there we go.
How many are you required?
1 million. I know. I know exactly what we have. I gotcha. This is exponential / logarithm word problem practice. Now, like I said, I am going to have that quizzes for you very soon, within the next 5 minutes or so. But first, I wanted to remind you of a couple of things that you're going to need to do on this particular quizzes. Number one, I would suggest having that calculator open on the screen when you're doing it, because you may need to use it at one point or another. I would also recommend that you have the pages to your notes open so that you can see what previous problems that we've done may relate to what you're doing then. First, I want to write down these two particular formulas again, because these two are the ones that come in handy more often than not. There we go. There's a little typo right there. That's okay. Move that up. That should be 1 minus r in the second one. These are your basic, straightforward exponential growth and decay word problem formulas. Depending on if it is a basic growth or a decay, you would use one formula or the other with the appropriate numbers plugged in. Beyond that, you also have these two formulas, which I am going to talk a bit more about in a moment. One being exponential form, and the other being log form. Move that up a little. There we go. I'm going to leave that on the screen for a little bit. These word problems that you are going to be faced with, you have to interpret what exactly it is that they're asking. Typically, you have to interpret whether or not the problem is a growth or a decay, and that will determine which formula you end up using at the top of the screen. Then, the problem may end up asking for you to solve for a different variable. For example, if I gave you the initial value, and I gave you the rate of growth, and I gave you a unit of time, all I may be asking is, well, what is the resulting value of the object in question? But if I give you the initial and the resulting, and I give you the rate, I may be asking, well, how long will it take for that object to gain that value to become this? If I have a house that's worth $100,000, how long will it take for that house to reach a value of $200,000? And if I'm asking the question, how long, you are solving for the variable. I'm sorry, the variable. You are solving for the exponent. This is where the bottom of the page comes into play. If you are solving for the exponent, you need logarithm form. I'm going to show the calculator real quick to kind of reiterate that point. But yeah, you will need logarithm form. Logarithm form is only needed if you're solving for the exponent. That is something that you have to drill into your head. Logarithm form is only needed if you are solving for the exponent. Please keep that in mind. So, for example, and again, I'll go to the calculator real quick with this example. If I had the problem 200 equals 10 to the x power. If I had 200 equals 10 to the x power, or more typically 10 to the x equals 200, and I have to solve for that exponent, logarithm form would be my best bet. If I convert this exponential form into logarithm form, well, let's see. The b is 10, the y is 200, logarithm form gets the x by itself. This would be log base 10 of 200 equals x. And at that point, I would go to the calculator and utilize the function that we need to use. If this thing will load. There we go. As a reminder, math log base. Math log base. Log base is under that function of math, and you can type in the appropriate numbers. And it will spit out the answer that you were looking for. If you hit the math button is in the left column, right here. And you go down to option A, which is log base. Hitting log base will bring up that function. Now, here's the interesting thing. That function is only on the 84s. It's only on the TI-84s. You have a calculator on your phone, but your phone does not have that function. I'm sorry, let me rephrase. It doesn't have the one where you can change the base. This one, you can change the base. If I brought up the calculator on my phone right here and turned it to the side, oh, you can't see it. There we go. Oh, come on. There it is. If you turned it to the side like so, zoom in on that, it does have a log button right there. Oh, now it's not focusing at all. There it is. It has a log button right. Oh, hold on. What if I just focus with my hand away first? Wow, that's absolutely terrible. I'm not even doing anything. Whatever. It does have a log button, but the way that you would actually have to calculate that thing would be like this. You would have to do log of 200 divided by log of 10. That is the change of base formula that I've given you guys in the past, where you would take the log button is on the front of the calculator and on your phones, but log of the number divided by log of the base. Clearly, it gets the same answer, but thankfully, you guys have the TI-84s. So, if you do not already have your Chromebook out, logged on, ready to go, please make sure that you do so, because I'm about to throw this quizzes at you. After said quizzes, and I do have a hard stopping time that I would like to stop it at if you haven't finished. But after said quizzes, I would like to go over the problems that gave us the most trouble. Just for the sake of argument, I want to see if you guys can actually beat yesterday's class. Yeah, yesterday's class had 47%. I want to see if you can do that. Click. For those of you in the chat, I figured out, actually, that if I make the browsing window full screen, you can easily see the code that's up there. But just in case, I'm going to type that code into the chat right here. 539632. 539632. Yes, let's get in there now. Let's get in there now. While you guys are still logging in there, because I only have 7 in there so far, while you're still doing that, let me just give you a reminder. Yesterday, I posted a very important message into your Google Classroom stream. Several of you have already talked to me about that, which is great. But let me just give you a little bit of background. In the past, people have asked me individually about possibly retakes or things along those lines. And yes, there is a retake policy that has been mentioned in the past. Not often, though. But because several people asked me about that particular major, I decided to do a blanket offer to everyone that if you want to improve that major assessment grade, follow the directions that I posted on Google Classroom. Follow those directions. Email me if you have any questions. And we'll kind of get this thing moving. Who's that? Who's that? I know who that is. Anyway, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hold on. There's a bell.
Please excuse the interruption. Maya Worthy. Please report to the main lobby. You're being signed out. Maya Worthy.
Now, there are 11 people in this classroom, and there are supposedly 5 people in the chat, yet I only have 11 people in the quizzes. That's a problem. Perhaps people in the chat are showing their hand of, I don't know. I know what they do. Put me on mute. That's on them. That doesn't reflect kindness. Anyway, you can still log on even after I click to start this thing, but I'm going to start this thing now. So if you haven't gotten into it, please make sure that you do. Yeah, I'm going to kick these names because I don't know who they are. And I'm going to ask that people actually do put their real names on there. I don't know who Sir Cartier is. I'm going to kick that too. And I'm going to ask that you log on with the code with your name. Here we go. Make sure you're getting in there with your real information.
But I can't go to the one.
Two different names.
So if mine, I did this one.
Ah, and then it allowed you? Type in your name, but type in different.
Yeah, but it says that you can have more than some.
I know why, because I think I only did one login for it.
Accidentally, yeah, accidentally.
So it won't let you do it again, huh?
Nice.
Here's what you do. Go to the quizzes website, the actual quizzes website. Okay. You gotta get on the website. There you go. Are you logged in under anything? No. You're in. Log out. And then are you able to try the code now? After you've logged out. Give it a shot. You have a separate account that you can do. Give it a shot.
Your coffee stuff.
What's my boiled water?
Yeah, it still says. I'll make a whole.
Well, that doesn't take that long. It doesn't let you with the first one. That's so weird.
Just try it out.
Oh, let's see if it works. You leave the space. Allow him to join the.
I really did a whole. I was still logged in.
Gotcha. There we go.
How do we get to A?
Was that?
On the calculator, how do we get to A?
You just go down. It should be under the, yeah, logos. Yeah, and I'll bring you to the little screen where you can type in the little subscript of the number. You know how to set it up, but you don't have to calculate it. Well, I would set it, you can set it up on paper first, so you know what it is that you actually have to calculate. Well, that's what you gotta tell me. But remember, that's why I went over these things originally. To remind you guys. So you're trying to figure out the resultant value of y.
Yeah, so what I just, okay, here, what,
Well, you don't have to do the y. If you type it in as is, you should be fine. Keep in mind that 5% can't be written as a 5.
but the one stays there, one plus.
Yes.
How do I get the,
Caret symbol. There's a couple different ways to do the caret symbol. You can do, where is it? Shift 6, I believe, will work. Yeah, but there's also a caret symbol right there as well. Did you type in this 0.5 or 0.05? 0.005, that's a 0.5%.
so. So I'm close to saying this, but you guys include the one plus or,
In the 4 options, they are either all 1 plus or 1 minus. So for this one, it's just a matter of recognizing which one is the proper setup for this problem. What's up?
Verbally, what you just described to me was finding the linear change. But this isn't a linear change. This is an exponential change. You have the initial value, you have the resulting value, and you know how much time went by, right? And you know that it's like kind of like population double in years. Literally from this branch, you could, what's what I'm looking for? You probably logically guess what the answer is based on the way that it's worded. Sometimes. Because it more than doubled after 45 years. You know what I'm saying?
I'm going to give you guys about another minute or so, and then I would like to go over some of these more difficult problems. Okay. I'm going to end it on that one, and I want to take a look at some of the red labeled questions. So we can kind of see what to do with this. Taking a look at these questions, sort by accuracy. Let's start at the bottom right here. What I'm going to suggest to you is that the problems that we are currently writing down, I want you to put into your notes. So as a continuation as to what we were doing, I definitely want to write this information down into my notes. You won't need the Chromebook because I'm going to flip back and forth so you can see exactly what I'm writing so you don't have to strain at the screen. Let's see what we got here. There we go. Zoom back out. Focus in there. There we go. I do have the chat open in case there are any particular questions. This is the quizzes review for the problems that we just did. So let's start with this first one. Okay. I'll show you what I'm writing in a moment. There we go. This problem was the most difficult problem on the quizzes according to the information that they gave me. And they wanted to know what was the rate of growth. Now, in a moment, I'm going to check to see what the majority of people picked for this particular problem. Let's take a look. Looks like most people picked 1.16. Now, the key word here is rate, the rate of growth. They want the value of R. Now, what I wrote for you when we started this thing, today that is, was the following calculation, the following formula, in which the rate of growth would be that value of R. Most of you picked 1.16, which would be the, well, technically it's called the growth factor, but it is definitely not the rate at which this thing is growing, because you would have to recognize R equals 0.16, which is that 1 plus R. We need to be careful with the wordings on these problems. We have to be very careful with the wordings on these problems. Cha-cha. There we go. Let me see. What most people did pick the 1.16, and then, yeah. What is the 300 here? Yes. Chapow. I make sound effects. 1 plus R is what is inside the parentheses. It's 1 plus the rate at which this thing is growing. They give it to you as 1.16. So it's like, what do? You have to separate it to 1 plus 0.16. Yeah. They gave you the 300 here, and a couple people chose 300. What is 300 in the context of the problem? What is 300 in the context of the problem? Yeah, whatever the heck it is, but yes, it's the initial value. It's what you started with. And remember, X is time. It's the time unit. All these different components make up the exponential. Let's see here. The next most difficult problem, perfect. I love this problem. Let's talk about why. I'll write this information down and then flip my screen. A car is valued at $22,000 and it depreciates. What is depreciation, by the way? Yeah. So this is an exponential decay. It depreciates at a rate of 9% per year. How many years will the value have to depreciate to $9,000? Here's what I wrote down. And I would like you to write down the same thing as well. My wife and I are currently in the market to potentially purchase a car. I shouldn't say a new car, because I don't want to buy a brand new car because they depreciate very quickly. I would rather say I'd like to buy a new to us car, because currently I'm driving a 2005 Honda. 2005. Think about how old you are in 2005. That's how old my car is. But we're in the market for a new car because at this point you have to consider, well, how much will it cost to repair the thing versus how much is the value of the car? You have to make these types of decisions eventually. But we have a car that we purchased for $22,000. It depreciates at a rate of 9% per year, which actually is pretty darn good. Cars typically depreciate 15 to 20% per year in real life. How long will it take until it reaches a value of 9,000? I need logarithms to solve this problem. How do I know that? Because the variable is the exponent. I'm solving for the exponent. Because of that, I need logarithms. Eventually, I'm going to have to convert this thing to logarithms. According to the order of operations, please excuse my dear Aunt Sally, when do logarithms take place? Yeah, they do fall under the category of exponents, which means before I do logarithms, I have to get rid of this 22,000. I have to get rid of that 22,000 by dividing. So I'm going to go to my calculator. I'm going to zoom in on this sucker. I'm going to have to take 9,000 and divide by 22,000. I do not feel like writing down that decimal. Hold on, announcement.
Please excuse the interruption. Connor Donahue, please report to the main lobby. You're being signed out. Connor Donahue.
I don't feel like writing down that decimal. I don't know if you guys know this little trick. Do you know this trick? If you hit math, the first option is frac, which most of the time, not all of the time, most of the time, it'll turn a decimal back into the simplified fraction, which is nice. It's very nice. Simplified fraction. So that's actually what I'm going to write down instead of that decimal. I'm going to divide both sides by 22,000, and that's going to get me 9 over 22 equals this. What the heck else did I do? I divided by 22,000, but what else did I do? Not exactly. It's a 9% loss per year, right? So it's 1 minus 0.09. All I did was I simplified what was on the inside of the parentheses. 1 minus 0.09 is 90.91. Think of it this way. If you are losing 9% of the value per year, what percent are you keeping? Exactly. That's the logic behind that. If you're losing 9% per year, you're keeping 91%, or you're retaining it. It's a weird process, but yes. This is the time for logarithms, right here, this moment. If I use that logarithm conversion, the base on my exponential is 0.91. And logarithms, I need you to put this in your heads. Logarithms get the exponent by itself. It gets the exponent by itself, whatever the exponent is. This is the logarithm that I have to calculate. This is what I'm going to type into that calculator in a moment when I walk over there or roll over there. Math, log base, 0.91, 9 divided by 22. Looks about right. 9.48. 9.48 what? It's a word problem. I need units. Say again? What's the rate measured in? Well, yes, technically, but what time unit is the rate measured in? Years. That's what your answer is measured in as well. Whatever the rate is measured in is the same time unit as the exponent. So in this case, it is years. Say who now? Yeah, 9.48. And you can even check that kind of. I mean, obviously, this decimal is what it is, but it's like 22,000 parentheses 1 minus 0.09 to the, well, that answer in terms of the number of years. 1 second. There's $9,000. Go ahead. If you rounded it? Gotcha. Let me go here. So it depends. For example, on this quizzes, they rounded to the 10th. So it'd be 9.5, right? A lot of the time on a state test or the SATs or what have you, sometimes in the directions, they'll tell you what to round to. Sometimes. Which is like, okay, that's cool, but there's no hard and fast rule. In reality, it's like if I just said, 9.5 years, that probably would be sufficient. If I rounded it down to 9 years, now I'm off by like 6 months. It's like it depends on the context of the problem. So, but definitely the directions, or in this case, the multiple choice answers will tell you. Let's see. Click. Okay. I'm going to circle back around to this problem because I want to talk about compound interest in a little bit. I want to do this problem. Yes, this problem. I'm going to circle back around to compound interest because I haven't. Well, that one you could have gotten done without knowing compound interest, but I do want to talk a little bit about compound interest in a little bit. First, let's talk about this problem here. 5 to the 2 minus x power equals 1 over 125. Do you guys know what 125 is off the top of your heads? Do you know what it is if you had to break it down? Some people know, not a lot of people do. If you don't know what 125 is off the top of your head, just try to break it down using like a factor tree or whatever. What can you divide out of 125? Clearly, yeah, you can divide 5. Clearly, you can divide 5. Hold on. Go to my calculator. Zoom in right there. 125 divided by 5. Oh, snap. Divided by 5. Divided by 5. It took me a few moments to figure it out, but 5 cubed is 125. Kind of. Let's work it down like this. The left side is still the same, right? The right side is 1 over 5 cubed. I don't want to leave it like that. I would prefer that 5 cubed to just be like a regular 5 and not a 1/5 like you're saying. I don't want it to be a 1/5. The rule that I have taught you is that when you have a fraction like that, if you rewrote 1/5 as a reciprocal, what is the reciprocal of 1/5? Just 5 over 1, but just 5, right? If you take the reciprocal, look what happens to the exponent. If you take the reciprocal of 1/5, that exponent turns negative. How does that help us? Well, now your bases are the same. And if your bases are the same, what do you know about the exponents? Yeah, they are. And now you can do this. If the bases are the same, then the exponents are the same. You can set them equal to each other, and now you can do junk like this in order to get that final answer. I'll scroll back to the top of the page in a moment. Here's the original problem up top. 125, it took me a few moments to figure out that 125 was 5 cubed. I can take the reciprocal of 1/5 and make it a 5, but my consequence is that the exponent turns negative. But the reason why I need to do that is because I want the bases to be the same. If the bases are the same, then I can set the exponents equal to one another and solve it like I was in Algebra 1. That's where that problem goes. Okay. Not that one. Not that one. Yeah, that one. Yeah. There was a huge mistake. My papers. There was a huge mistake that my class yesterday made that I want to point out to you. Not to make fun of yesterday's class, but as a lesson. 20 years ago, Mr. Davis purchased a home for $160,000. The value of the home has increased 5% per year. How much is the home worth today? Here's what I wrote down. Mr. Markey, I think that you are missing something. You clearly did not put in the 5%. I know, I didn't. I will, but I didn't for a reason. You guys didn't do this. Or I should say the majority of you didn't do this. It looks like only one of you did this. But yesterday, a handful of students all did the same thing. They wrote 5% as 0.5. What is 0.5? Yeah. If you do 50%, that's where this answer comes into play. That one on the far right. I'm sorry. If his home is $532 million, you sell. But it's not worth that much. You have to put in the proper decimal. 5%, you take 5 divided by 100, 0.05. That's what we have to type in. 160,000, parentheses, 1 plus 0.05 to the 20th power, $424,527.63. This problem just wanted the resulting value. It just wanted the resulting value, so all I needed was y. Every single one of these problems is going to give you just enough information to figure out what the resulting variable should be, whatever variable that is, whether it be y, a, r, or x. You have to read into the context, you have to plug into the appropriate location, and then you have to solve accordingly. Logarithms will only be needed if you're solving for the exponent. But if they give you the exponent, then you don't need logarithms. That's what these things will come down to. There's one more thing that I want to show you today, and I want to write this down, obviously, into our notes. And it is the idea of compound interest. What do your banks send you pretty much at the end of every month? Statements, and usually those statements include what? Purchases. That's true. But what does the bank give you for all of your hard work? Money. Kind of. Like a nickel for interest, right?
Yeah.
You have to do that every time. Now, the banks follow what is known as a compound interest formula. They found that you actually get slightly more money the more times that the bank compounds your interest. Most banks compound monthly, 12 times a year. It's very rarely that you'll find banks do more than that. There is the occasional bank that'll compound daily, which is 365 per year, I should say. Most banks will do monthly. Some will even occasionally do quarterly. So like quarterly, if you compound quarterly, that's 4 times a year. So every 3 months, something like that. But I need to give you the following formula. And it's a fancy formula. It's a very fancy formula with different types of letters in it. But it should be very familiar. This is the compound interest formula. This formula is very, very, very similar to what we have been doing with, and I'll write this down. I'll erase it in a moment, but y equals a parentheses 1 plus r to the x power. It's very similar. You remember what a was? The initial value. Well, now a is going to be this capital letter P, and it's going to stand for the word principal. The principal amount, the initial amount. It's the same thing. Mr. Markey, why are they changing the letters? Because people are difficult. I'm not even kidding. Like, they'll throw on like formula sheets for the SAT. On formula sheets for the SAT, they'll throw this formula at you and not this one. It's like, what the heck? R is still the same. R is still your rate, but then there's this extra little n here. What the heck's going on there? And that n is also up here. Hey, tell me, what was x? Time. Now we're going to use the letter T. That's actually quite nice for time. I'll write this stuff down. Say again? Oh, I'll talk about that. I'm going to write that down. Then this y is the resulting value. It's now being replaced with this capital A, which is the resulting amount. This is what banks use to calculate your compound interest. This is what they use to calculate, oh, now I owe you 4 cents this month. I'm not even kidding you. My TD Bank savings account, you know how much interest they gave me last month? 13 cents. Yeah, that's why I don't have all my money in TD Bank. I've talked about where I put most of my money. It's in a safe. And you don't know where it's buried. Anyway. P is your principal. That is still your initial amount. R is your rate. Now, typically banks will give you a rate, and those are annual rates, meaning per year. T is time, and for compound interest, it will also be measured in years. I already talked about what A is. I'm going to save a little time, and I'm going to tell you what N is. N is the number of times compounded per year. N is the number of times compounded per year. Meaning, if TD Bank offers compounding monthly, well, what's the value of N? Yeah, it's just 12. If they offer daily, go with 365. I know, 366. No, 365. Sometimes they'll do quarterly. And if it's quarterly, it's 4. Yeah, it's a repeated number. Mm-hmm. It's really weird, but this is what they do. This is what they do. They basically take that rate, which is already minuscule, and they break it up by dividing it by n. They get a number that's even smaller, add 1. Then they raise it to the nt power for the number of times compounded over the course of however many years you're going. It's really weird. It's really weird. But this is what they use. This is the formula that has been used to calculate compound interest. And it does make mathematical logical sense that it has been proven to work. But this is what they use. It's a takeoff on the original formula that I showed you, the y equals a parentheses 1 plus r to the x power. But it fancies it up a little bit so they can wear top hats and monocles and take more of your money. The bank is like Mr. Peanut. So anyway, we'll pick up with more of this next time. Pay attention to Google Classroom. Here we go. There's the bell. If you haven't left a comment in the chat, please make sure that you do so. And oh my gosh, it's Thursday. I'll see you on Monday. Goodness.
So how'd you call the bell though? What?
What?
I didn't know that you called the bell.